Okay, so in the interest of saving time and energy, uploading videos and making copies of things, I'm going to do everything from May 7th, which is these two problems, and this sheet here, finding or using square roots to solve quadratics in vertex form. So we're going to do everything that you might have missed on May 7th all in one video. So if you only missed part of it, you just have to fast forward. Okay, so in yesterday's solving a system of equations, we worked with elimination. So what we did was we had already set up a negative 4x and a positive 4x that was in the problem originally. So by adding up those two equations, we were able to reduce the x term down to 0x, which then when you add a 0, no matter what x is, 0x is going to be 0. So when you add a 0, it's insignificant. So that left us with 6y equals negative 36. And we were able to get that down to y equals negative 6. Then we took negative 6 and substitute it back into one of the equations for y. Now you could have substituted it into this equation. I just picked this one because it had these positive 4 and 8. But substitute negative 6, do your multiplication to simplify, so we get 4x minus 48 equals negative 24. We solve for x by adding a 48 to both sides and then dividing by 4, and we get that x equals 6. So the solution, that pair of x and y values that made both of these equations true at the same time, would be x equals 6, y equals negative 6. And then if we looked on a graph, which I think we did in the last video, the graph for each of these equations would intersect at this point 6, negative 6. And then we did the same thing over here with this problem. Now today, these were a little different because where up here we already had two terms that would cancel out, we don't have that here. So what I have to do is I have to multiply one of these things through by a number that's going to change it so that I can do what I need to do. So I have a negative 4x here. If I multiplied this by 4, I would get a positive 4x. I have a positive 9 here. If I multiplied this by 3, I would get a negative 9. So I could do either one, but since we started with y yesterday, started by eliminating x yesterday and solving for y, today I want to eliminate the y's and start out by solving for x. So the first thing that I have to do to solve for y, or to eliminate the y's, is I have to multiply this entire equation by 3. So when I do that, I get 3x minus 9y equals negative 18. So now I don't need this equation anymore. I've written a new one. Now I can go ahead and add straight down, and I get negative 4 plus positive 3 is negative 1x. My y's cancel out. That was the point. I had a positive 9y and a negative 9y. And then over here, 9 plus negative 18 is negative 9. I can divide both expressions by negative 1, and I get x equals positive 9. So I'll put positive 9 over here. Okay, so now I'm going to take my positive 9 and I'm going to substitute it back into one of these equations. It doesn't really matter which one, so I'm going to use the top one. So I've got negative 4 times positive 9 plus 9y equals 9. So that gives me negative 36 plus 9y equals 9. I want to add a 36 to both sides. That's an equal sign, by the way. So I get 9y equals 45. That's a 5. I divide both sides by 9 and I get y equals 5. So the solution, sorry if that was a little out of the picture, it's hard. There's a tiny little bit of a delay when I write on the paper versus when I see it on my phone. So I have to look underneath the phone. So I just want to point out that we said that the intersection, if we graphed these two equations, this would be the point where they intersect. So if you look here, the blue line is the graph of x minus 3y equals negative 6, and the red line is the graph of negative 4x plus 9y equals 9. And if we look in here where they intersect each other, we get 9, 5, which is our set of coordinates that we found. So what we're saying is that one solution, there's a lot of solutions that will, if you plug in an x and a y here, there's a lot of things that will turn out to 9. There's a lot of things that you can plug into this equation that will turn out to negative 6, but there's only one pair that works in both of them. Okay. So go ahead and pause the video, take a moment to work on your side over here, and then come back and see how you did. Okay, so in looking at these two equations, I noticed that I had a positive y and a positive y, so we were really close to being able to turn one of them just into a negative y. So I did the bottom one to kind of get rid of a bunch of these negative signs. So to turn a positive into a negative, we multiply by negative 1. So that gives us positive 3x minus y equals positive 5. So my middle equation, I can cross that out. I don't need it anymore. So adding straight down, 8x plus this new 3x gives us 11x. My y's canceled out, so that's what I wanted to happen. And then negative 6 plus 5 gives me negative 11. I divide both sides by 11, I get x equals negative 1. So there's my x coordinate. Take that negative 1 and I rewrote this top equation here, but I substituted negative 1 in for x. So that gives me negative 8 plus y equals negative 16. I add an 8 to both sides, and that gives me y equals negative 8. Now I saw a lot of people in class wanting to then divide by something because that's the next step. You add or subtract, then you multiply or divide. If it throws you off your process for solving these, remember we can always put a 1 in front of here, and then we can just divide both sides by 1 and we still get y equals negative 8. Okay, so if it really bothers you that there's nothing there to divide, remember you can always put a 1 in front of any variable that doesn't have a coefficient in front of it. Okay, and then I want to show you the graph of this one. The green line is the graph of 8x plus y equals negative 16. The purple line, that's this one right here, is the graph of negative 3x plus y equals negative 5. And if we go down here, we find the intersection at negative 1, negative 8, which is the coordinates that we got when we solved that system of equations. So good job. Okay, so the next thing is when we talked about vertex form of our notes yesterday and completing the square, what we said was completing the square gives us a couple of things. It puts a quadratic that looks like this into vertex form. And from vertex form, we can do a couple of things. We can pull the coordinates for the vertex right out of this equation or this expression, or we can solve it using square roots. Well, we already looked at how to do how to get the vertex out of this equation. So now today we're going to look at how to solve it using square roots. So we have an equation already set up in vertex form. Now, much like the using the zero product property or the quadratic function or the quadratic formula, in order to find the zeros, your equation has to be equal to 0. That's what you're looking for, is what input for x produces 0 for y. So we'll get to that in just a second, but we also have to get it into a 0 equal to 0 situation in order to pull out the vertex as well. So I need to actually solve this or rearrange this a little bit so that it is equal to 0. So I can do that by subtracting 34 from both sides of this equation, and what I get is x plus 3 squared, and that's actually going to be minus 25 equals 0. So now I've got my vertex form of my equation. The vertex, remember, the x-coordinate is always the opposite of this one. So this is positive 3. So the x-coordinate is going to be negative 3. And then the y-coordinate is always just this number right here, so negative 25. So we found one really important piece of information, that negative 25 gives us the minimum of our function. So it's the lowest most point of our function. So now we're going to look at what the zeros are and how to find the zeros using the using square roots. So we start out with our equation x plus 3 squared plus 9 equals 34. And we want to make that equal to 0. So we're going to subtract, again, we're going to subtract the 34 from both sides. Because what we're saying when we say find the zeros or find the solutions is what value of x makes the equation equal 0. Or what value of x produces an outcome of 0. Okay, so now we have to look at what's happening to our x in this situation. So first thing that's happening to x is that it is, if we went through the order of operations, we would be adding a 3. So I'm going to make a little list over here. So plus 3 is the first thing that would happen. Once we have those parentheses taken care of, we would square it. So I'm going to put SQ for squared, and then we would subtract 25. So we're going to deal with these things backwards as we're solving the equation. So we're going to deal with the minus 25 first by adding 25 to both pieces of our equation. So we get x plus 3 squared equals positive 25. Now notice we could have gone ahead and moved this over. We could have just added a 9, or I'm sorry, subtracted a 9 from both sides. But I did this a little bit longer because I wanted you to see that it has to, what we're looking for is what value you put in here for x that makes this equation equal 0. Because you then take this number and the first thing that you do is move it over here, you don't really have to make it equal to 0. If we had just subtracted a 9 from both sides, we would have ended up with the same thing. So you really could skip down, you really could skip this step, making it 0. But I want you to keep in mind that that's what we're doing, is we're finding what would make this equation equal to 0. So now we've taken care of the minus 25. Now we need to take care of the squaring. So the inverse of squaring something is taking the square root. So the square root of x plus 3 squared is the square root of, is equal to the square root of 25. So the square root of x plus 3 squared is just going to be x plus 3. And then remember, the square root is a positive or a negative 5. Because remember, positive 5 times positive 5 gives us 25. So does negative 5 times negative 5. So now I took care of the squaring. Now I'm going to take care of the plus 3. And I do that by adding a minus 3 to both sides, or a negative 3. So this is, x is going to be negative 3 plus or minus 5. So remember, this is a parabola. This is a quadratic equation. So that means that we're going to have two solutions probably. Unless your vertex doesn't fall, unless your entire graph falls above or below the axis, the x-axis, or your vertex touches the axis, you're going to have two solutions. So this is going to break down into x equals -3 plus 5, or I guess we should say and x equals -3 minus 5. So if it were x equals -3 plus 5, that would give us +2, and then x equals -3 minus 5 would give us -8. And if we look at our graph here, let's take a quick look at the graph of this function. So way down here at the bottom of the screen is the vertex, which we found to be -3, -25, and sure enough, our graphing app agrees with us. Now if we go up here to find the zeros, we're looking for +2 and -8. So over here, if I click on there, there's the coordinate of that solution, 2, 0, and over here should be -8, 0. So according to our graph, our solutions are correct. All right, so take a minute, follow these instructions, and work out your problem on the right-hand side, and then we'll come back and check it on paper and with the graph. All right, so I subtracted subtracted 21 from both sides of this equation to make it equal to 0. And in that case, we're able to find the vertex. The vertex was at the opposite of 8, so -8, and then -16. So now if you see here, I skipped the portion of this that I did over here where we made it equal to 0. You don't really have to do that step. So we have the first thing that is happening to x is that we're adding 8 to it. The second thing happening to x is that we're squaring after we've added 8, and then we add 5 when we're done. So we're going to start with the -5 or the +5 by subtracting a 5 from both sides. That gives us 8 plus x squared equals 16. So we took care of the +5. Now to get rid of the squared, we take the square root of both sides of our equation, and we have x plus 8 equals positive or -4. So we've taken care of the squaring. And then we subtract an 8 from both sides to take care of the +8. So that leaves us with x equals -8 plus or minus 4. So we break that down into x equals -8 plus 4 and x equals -8 minus 4. So x equals -8 plus 4 gives us x equals -4, and x equals -8 minus 4 gives us x equals -12. So if we look at the graph of that function, we said our vertex was at -8, -16, and if we look down here, that's our vertex, -8, -16, and we said our two zeros are at -12, which is right there, and -4, which is right there. So we will continue working on the remainder of these problems in class today on Wednesday. So if you miss them, or if you need to go back and look at things again, please make sure that you do that. And hope you learn lots. We'll also be covering this topic in Algebra Bootcamp. So if you come to Algebra Bootcamp today, Wednesday, or tomorrow, which is Thursday, you'll get an opportunity to review some of this stuff. All right, have a great day.